Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
According to equation 27.4, energy is equal to the Planck constant time frequency, and since frequency is the speed of light over the wavelength, we can use that over here and we get the energy to be hc over lambda. So from this equation here, we see that the maximum energy is emitted when the wavelength is the smallest, or when the shortest wavelength is emitted, and that appears to be, let's call this lambda maximum, because this corresponds to the maximum energy. So that is equal to 0.025 nanometer. And similarly, the minimum energy is emitted when the longest wavelength is emitted. So let's call this lambda minimum, and this appears to be 0.2 nanometer. Now notice that this wavelength itself is not maximum or minimum, it just corresponds to the maximum or minimum energy. You can write it to be lambda minimum or lambda maximum if you want. Doesn't really matter. So we use these equations to find Emax, which is hc over lambda max, and we get this value to be around 40. Okay, one thing to notice that the answer you'll get here will be in joules. So we want to convert it into electron volts. So we need to divide it by a factor. So this is basically in joules. So we need to divide it by a number that corresponds to how many joules are there in 1 electron volt. And then we get the answer to be 49,725 electron volt, and we can take an approximation and write this to be 5 times 10 to the power 4 electron volt. Now we do the same for the minimum energy. So this will be in joules again. Let's just write joules here, and again we have to divide it by how many joules are there in 1 electron volt in order to convert it into electron volts. And we get this value to be 6215 electron volt. This is nearly 6 times 10 to the power 3 electron volt.